This is going to cover section 1.2, operations on functions. The goals of this video is to discuss compositions of functions as tables, graphs, and formulas, as well as transformations of functions in their graphs form. The definition of a composition of a function is that when the output of one function is used as the input of another, we call the entire operation a composition of functions. We write f of g of x, and this is read f of g of x, or f composed with g at x, where x is the input of g, and the output of g evaluated at x is the input of f. An alternate notation for composition uses the composition operator, an open circle, and we read it f of g of x as well, or f composed with g of x. The order is important. Whatever function comes second will be the inside of the function. So composition using tables, graphs, and formulas. When performing composition of functions using tables, graphs, or formulas, we start evaluation from the provided input and first evaluate the inside function. We can then use the output of the inside function as the input to the outside function, and so we'll always remember to work from the inside out. So let's start by using the table to evaluate f of g of 3. We'll do the same thing with the formula, and then we'll do the same thing with the graph. So starting with the table, what we want to do is first evaluate g at 3. So this tells us to look at x equals 3 and find the y value of the output when we're evaluating g of 3. So what we see from this is that g of 3 equals 2. And then we'll use that as the new input for f. So f of g of 3 will now be f of 2. And we'll look at 2 at the x value and look at the output of f. So f of 2 is 5, telling us that f of g of 3 is going to be 5. Let's take a look at this example using the formulas. So if I want to find f of g of 3 using the formulas, I want to start from the inside and plug in 3 into the g of x formula given. So g of 3 will be 3 squared minus 5, which is 9 minus 5, which is 4. So we have that g of 3 equals 4, and our function f of g of 3 now becomes f of 4. We'll take the 4 and we'll plug that into our f of x function and evaluate. So f of 4 is going to be the square root of 4 plus 2. The square root of 4 is 2 plus 2, which equals 4. And so we have f of g of 3 equals 4. Finally, we want to evaluate f of g of 3 using the graphs. Again, we want to start with g of 3, so we're going to start on the g of x graph when x equals 3 and find the output. So when x equals 3, we go up until we hit the graph, and the output is 4. So we're looking at f of g of 3, which is f of 4 from the g graph. And then we'll go to where x equals 4 on the f graph and the output is 0. So f of g of 3 from the graphs is 0. Now, when we want to talk about transformations of functions, it'll again be beneficial as it was in the previous video in section 1.1 when we talked about the definition of functions, to review the basic toolkit functions in your book, and that's going to be on page 12. And all of the transformations that we're going to discuss throughout the rest of this section will refer to those basic functions, which we'll call the mother functions. They're basically like home or starting. So if we are going to have a vertical shift in our graph from the original f of x, we define a new function g of x as f of x plus k. Notice that the k is on the outside of the function notation. It's not inside the function notation. So we're adding two y values together. K is going to be a constant, and g of x is going to relate to f of x as a vertical shift of f of x. Now that vertical shift will be up if k is positive, and the vertical shift will be down if k is negative. Alternatively, if we want to make a horizontal change to f, the new function g of x, which is defined as f of x plus k, notice now the k is inside the function notation, so these are adding two x values together. Then g of x is a horizontal shift of f of x. So here the difference is going to be that if k is positive, the graph is going to shift to the left, and if k is negative, the graph will shift to the right. The next type of transformation that we'll see is a reflection. So given a function f of x, if we define a new function g of x as negative f of x, then g is going to be a vertical reflection about the x-axis, so vertically over the x-axis. Alternatively, if g is defined as f of negative x, this is going to be a horizontal reflection or a reflection over the y-axis. And for a vertical stretch or compression, since it's a vertical change, we're going to be altering our output values. So if g is defined as k times f of x, then it's a vertical stretch or compression of f of x. When k is larger than 1, it's going to be a stretched graph. If k is between 0 and 1, then the graph will be compressed. If k is negative, then it's going to be a combination of a vertical stretch or compression with the vertical reflection that we discussed in the previous block. Now let's combine all of these transformations together. So when combining vertical transformations written in the form a times f of x plus k, these are all changes to the y values because we're multiplying a y by a constant and we're adding. We first vertically stretch by a and then vertically shift by k. The reason we do that is because of order of operation, which tells us to do multiplication first and then addition second. So we want to explain in words the transformation that would be applied to f of x equals x squared to obtain g of x equals 4 times x plus 1 squared minus 5, and we'll graph both functions on the same axis. So from your basic toolkit, you should know that f of x equals x squared is a type of quadratic function that we identify as a parabola. Why don't we start first by drawing our basic function, our mother function, that's where we start our home base. Here's our f of x equals x squared. So let's talk about first in words how we'll obtain our transformation g of x from f of x. So again, by order of operations, we'll start from the inside transformation, which is going to be this x plus 1. And remember, if it's on the inside, we're adjusting x's. Since the value on the inside is positive, we're going to be shifting to the left 1 unit. Then we'll vertically stretch by 4, and that is because we are larger than 1. And then we'll shift down 5 units. And so the vertical stretch by 4 has to come before the shift down 5 units by our order of operations that we talked about at the beginning of this page. So in words, we will shift f of x to the left 1 unit, vertically stretch by a factor of 4, and then shift down 5 units. Okay, now let's graph the transformation that we discussed in words. This is our g of x transformation, which is 4 times x plus 1 squared minus 5. In the next video, we'll discuss linear functions.